Hey, welcome back to another great RC Worst video. Today we are going to be showing you how to determine what size pump is in your well using limited information. So let's get started. Alright, so before we get started, I just want to show you how to figure out what you've got as far as a motor on a two-wire system where you don't have the control box. So we're trying to figure out the horsepower in this situation, which is going to give us more knowledge as we start to look at the other details of the well, so we can figure out what the pump and the motor combination is. So with the two-wire, obviously you don't have that control box, so you can't just go up to it and say it's a 1 horsepower, it's 2 horsepower, what have you. So we're going to show you two quick methods that you can use to figure out what horsepower the motor is, so that it can, you can get one more piece of the puzzle and we can figure out what you've got down in the well. So the two things, you're going to need an ohm meter or an amperage meter. So one of the two you're going to need in order to get this done. So the first one is if your pump is still running, and we'll kind of talk about that a little bit. So if your pump is still running but you need to know what the motor horsepower is and you don't have any record of it, you can take an amp reading. So, and I would recommend doing both of these just to kind of verify your results and kind of double check your work. But you got 1/2 horsepower, 3/4, 1.5 horsepower. They all have different full load amperage ratings and they all have different resistance ratings. Not to say that a 3/4 horsepower could not pull 5 amps or 1.5 horsepower could pull 5 amps. It's possible, depends on the loading. So we'll get into that a little bit. The best thing to do if the pump is still running, take an amperage reading when it's running wide open. So whatever you can open to get the pump working at its maximum, to get it closer to its full load amperage is going to help you in that determination. At the same time, you can do a resistance check. So you can check the winding resistance of the motor. So it would be the two leads, not the ground, but the two leads of the motor checked together with the ohm meter. And then you could figure out what your resistance is going to be. So you can see once again, they all are going to have much different resistances. A 1/2 horse, 4.2 to 5.2, whereas a 1.5 horsepower is 1.5 to 2.1. Fortunately, there's not really much overlap between these numbers. The only thing that you do have to account for is the length of wire. So if you're using your AIM manual, the Franklin Electric AIM manual, we'll put a link in the description below. It's, like I've mentioned in many previous videos, the best book for troubleshooting and finding information out about your well. That AIM manual is going to have some charts in it that show this information. I didn't put the 115 volt up here. We're only showing 230 volt, so I'll just throw that out there as well. So this gives you two options, two ways to check. Now, if your motor's not running at all and everything's dead, you're going to have to rely solely on the ohm readings, but it can get you very close. If you know just a few other small pieces of information, you can figure out what you've got by just narrowing it down. So now let's jump into actually figuring out what you've got now that we kind of have this information, and we'll talk about 3-wire motors using your control box and so on and so forth. Okay, so the first one that we're going to talk about is what I call the reverse engineered method. And basically what this method does is, in a situation where somebody's looking at replacing a pump and they don't know exactly what model pump they have or what brand pump they have or any of that information, they basically just are in the dark as far as what's in the hole, we can take a look at the information that we do know about the well to figure out exactly what we've got in the well. So to boil it down, the two most important things, the two most important ingredients that you're looking for in any of these scenarios to kind of validate your data against is going to be head, your total head, that's your friction loss, everything involved, your total head, and your flow, or the flow rate that you're experiencing, not the flow rate that the pump's capable, but the flow rate that you're experiencing. So with those two pieces of information, and we're going to talk about how you get to those pieces of information with limited information. So anyways, back to the reverse engineer method. What this one involves is, so like I said, you don't know what you've got down the hole. So you're trying to figure that out. So in this situation, you're wanting to use information that you do know. So let's say you've got a control box, and if you don't, we talked about what you need to do in order to figure out what horsepower you've got. But if you've got a control box, you go look at the control box and figure out what horsepower it says on the box. They're always going to say, in 99.9% of situations, what the horsepower rating is if you've got a start box for your pump. And now that we know the horsepower, we've got a huge piece of information, and that's going to help us in just a second here. So the next thing that you're going to want to try to figure out is, what other information do we know? Do we know the depth of the well? Do we know what depth the pump is sitting at? Do we know what the recovery rate is of the well? Do we know the static water level of the well? All these pieces of information can be combined to kind of draw a conclusion about what you've got in terms of a pump. So just to recap, the pieces of information that you're looking for are ultimately head and flow. But in order for us to figure out what we've got, we're going to have to fill in some of the blanks here. The more the better. So horsepower, we've already talked about how you can figure out what you've got there. So that's going to help us out here. Now the next thing we're going to focus on is well depth, static water level, and recovery rate. These pieces of information in a lot of wells, most of the wells, pretty much across the entire U.S., all wells drilled between the 70s and 80s. At some point, it was kind of a slow adoption, but at any rate, states started requiring that well drilling reports be kept with the state so that they knew what the water consumption was and they could get a better idea of what water usages were and so on and so forth. But at any rate, there's a good chance that you have this information available at your local office. So if I were, for example, I'm in Kootenai County, Idaho, so if I type into Google Kootenai County well drilling reports, then I can very easily pull up well drilling reports, and they go all the way back to the 70s here in Idaho. So it's really handy, and you can fill in all of, my pen, all of these key pieces of information. Now, you might be surprised to know, without even knowing flow or really all of our head, but just this little bit of information, we can figure out pretty much what we've got down the hole. Another thing that you want to consider is, and this ties into it, but pressure. So most systems are operating on a pressure switch. So if you're on a pressure switch, underneath the lid of the pressure switch, it's going to say the factory preset pressure. In most cases, for submersible, you're looking at 40 to 60 psi. So when we're talking about pressure, we're talking about what pressure the system's operating at. When we're talking about head, we're talking about a combination of the pressure and the lift and the friction loss that goes into getting the water to your home or to whatever the application is. So when it comes to head, we do have a video that we've done on pump head. So I recommend you watch that so you can get a deeper understanding of how head in terms of elevation and pressure kind of mesh together. I don't want to kind of get too far into that, or this video is going to be an hour long. But the relationship is there, and when you know what the head is based on these pieces of information, you can very easily figure out your total head. And now we've got that information, and if you know what your recovery rate is, then you're looking even better, because once you know the recovery rate, you can estimate flow, and you can figure out kind of what pump is going to work best for you in those situations. Just the same, if you don't know the recovery rate, or maybe it wasn't included on the well driller report, or maybe you just happen to know what the well depth is, you can use the well depth as well as the horsepower rating to essentially determine what flow rate pump you've got in the well. So it's just a matter of basically looking at the pump curves and then finding what horsepower corresponds with your well depth, and then moving your finger across until you encounter a flow rate that makes sense for that particular depth. We do have a really nice video on how to read a pump curve, so check that one out as well, because that kind of ties in. If you know how to read a pump curve, you'll definitely understand the relationship between your depth, operating pressure, and then the flow. So knowing just those key bits of information, you can essentially figure it out. Now, the secret behind the reverse engineer method is it's actually just basically sizing a well pump for your application, but the more information that we get, the more accurately we can size it to what you had previously, and oftentimes that's the goal. If you've had a pump installed for a long time and you just want to replace it like for like and get your system back up and running, get back to life as usual, then this is a good method to use, but it's ultimately just sizing a pump as if it was a brand new installation, and we're just trying to get pieces of information to try to get as close, if not exactly on point, in terms of replacing it like for like. So if you have any questions on this method or trying to figure out what pump you've got in the well, just get a hold of us. So we're gonna jump into the next method, then we'll kind of bounce around a little bit from there. So now we're going to talk about what I like to call the mystery pump method. Get to put on our Sherlock Holmes hat and talk about the mystery pump. No, basically what we're referring to when we're talking about a mystery pump is in a situation where you've pulled the pump out of the well and you need to get a new pump ordered, but you don't know what the heck you've got. A lot of times on a pump, like here's one for example, you've got all of your labeling and model number, horsepower, flow, all that information on the pump, and normally it's located towards the bottom in most cases. Sometimes it's on the top though. We got another pump in here, and this one's paper, so that wouldn't last forever. But this one pump has been installed for a long time, made in 2011, or had been installed for a long time, and the label held up. But anyways, getting off the rails. But when it comes to identifying your pumps, it's very, very common to not be able to identify it. Sometimes the corrosion's so bad, you got to scrape the label off to read it, in which case you can't read it because you scraped it off. So being able to determine what pump you've got is obviously the goal. So there's a lot of things that you can do to figure out what you've got. You can measure the length of the pump. You can figure out how deep the pump was sitting. And now that you've got the motor and the pump out, you can look at the horsepower and then compare that with the depth and find a good curve that intersects based on, once again, like we mentioned in the first method. So we're just looking to fill in the missing pieces of information and essentially re-engineer it with the information that we do know, and then we can kind of assume a few things based on what we find. Okay, so like I mentioned, measure the length of the pump. That's kind of the key ingredient on the mystery pump method. So what you're looking to do is either measure from the bottom of the pump where it connects to the motor to the very top, or measure the entire length of the motor, but you need to know the model of the motor so that you can figure out how long it is and subtract that from the length of the pump. Oftentimes, if I'm telling somebody to do this over the phone, I'll ask them for both measurements so that I can verify that the measurements line up with what they think they have and what they've measured. But in reality, all you really need is the length of the pump and to know where the pump stops and starts. So with the length and knowing what the horsepower is, we can very easily figure out essentially how many stages it is, because at this point you've pulled the pump out of the well, so you know how deep it's sitting, and then we know the length, so we basically know the number of stages, which, to kind of explain that a little bit, inside of a submersible pump you've got multiple stages, or the impellers are just stacked up on top of one another, and so adding a stage increases length. So once we kind of know how long it is, there's kind of a standard for, okay, so it's 12 inches. Well, a 12-inch pump that hooks up to a 1 horsepower motor, for example, there's only maybe one that matches that length in that horsepower, so it makes it easy to kind of narrow down what you've got. And what you're going to have to do in those situations, now you can make it easy on yourself and just call me up and say, hey Chris, I've got a 12-inch pump, I've got a 1 horsepower motor, what am I looking at? Or you can flip through the catalogs and kind of look at what the lengths are of the various pumps in different flow ranges with different horsepowers, and you can figure out essentially what you've got. It might not be the same brand. But it doesn't really matter. They're pretty uniform. You might be surprised to find out that they're pretty uniform. The only real difference is the discharge head length. And here's actually these two pumps are a good example of that. So this one, the discharge head is kind of recessed into the top of it, so it doesn't stick up real far. But this one, the discharge head kind of sticks up a ways. So your numbers aren't going to necessarily line up exactly unless you're looking at like for like brands. But oftentimes, even that 1.5 to 2 inch difference, you can kind of narrow it down between only a couple that really make sense, and generally only one that's going to intersect in the right spot on the curve. Again, you're going to want to be looking at operating pressure, figuring out that head and that flow rating, or at least one of the two, so that you can get an idea of which one of those curves you're looking to intersect with. So, on to the next method. Time for a pro tip. So the pro tip this episode, if you don't know what the pressure setting is on your pressure switch, or if you think it may have been adjusted, assuming the rest of the system was set up correctly, check the pressure in the pressure tank. The pressure in the pressure tank always needs to be 2 to 3 pounds below whatever your pump turn on pressure is, your pump on pressure. So if your pressure tank's at 38 psi, you can pretty much assume that your pressure switch or your pump turns on at 40 psi, and in most cases that means it's going to shut off at 60 psi. So when there's doubt on the pressure switch, or maybe it went missing, or who knows what happened, or maybe the cover went missing, you can figure it out basically just using the pressure in the pressure tank. Okay, so we're up to the next method. This one's called the count the stage method. So we've talked a little bit about stages and how it relates to the length of the pump, but if you just know the number of stages, then you can skip the whole measuring bit and tell me how many stages it is, what horsepower it is, and boom, we got a pump figured out. So a good example of a pump that you would want to count the stages on would be a pump like this. So this happens to be a Grundfos pump, and you got to be cautious though, because it's not as straightforward as it might seem. There's kind of what I like to call false stages, because they're not really stages even though they kind of look like they are. So on this pump you can see we've got a cutout, so you're not going to have that convenience unless you want to and get the grinder out. But anyways, so this pump has 1, 2, 3, 4 impellers. But interestingly enough, if we were to count it, 1, 2, 3, 4, 5, 6 sections. So it kind of depends on how the pump is designed, and sometimes you can just look down in the discharge and determine whether or not there's a false stage at the top, but you never really know about the bottom one, because if I were to tell you to count the stages and it's just the ribs, you'd say 1, 2, 3, 4, 5, 6, and then really we've got a 4-stage pump, so we could be way off, and you'd end up with a way lower flowing pump, because typically the more stages, the more pressure, but usually the less flow, and then the other way around. Less stages, more flow, less pressure. So anyways, the count the stages method is really nice if you've got a pump like this where it makes it pretty easy. You just got to be aware that it could be a false stage. So the bottom one is just basically the bottom coupling that the first stage goes into, and then it kind of works its way up to what this is the check valve, and that needs a place to sit. So this is the way this particular pump is built. And an example of a pump that would be, you could count the stages on this pump, but it would be much more difficult because you'd have to disassemble it. So this top of this pump is just threaded on here, so you can just unthread it, which I'm not going to do because I need a vise to get it off. But at any rate, and then you can just pull the stages out. But keep in mind, proceed with caution, I guess I should say, because a lot of pumps, this part is not threaded. It's not intended to be taken out. A lot of times if you look at it real close, you'll see that there's like the metal kind of does, let me draw it so I'll show you. So a lot of times you'll have like the metal go up and out, and then it'll end like that. And basically what they're doing is they're putting the discharge and they're sealing, the plastic kind of like seals in this section, making it impossible to get it out. And you could rotate it for 100 years and you would never have any threads. It would just it's kind of like a crimp. And a lot of less expensive pumps where they don't want to pay for that additional machining of the threads and of 2 different components and so forth. This is pretty common on your cheaper pumps. So just be cautious of that if you're trying to pull those apart. We did a video, I believe, where we took apart a pump similar to this. I think it was an Orenco pump, so a high head effluent pump. We talked about replacing the stages. So if you are curious to see how that goes, look for that video. We'll see if we can dig it up and put it in the link below. We'll see how that goes. But I'm pretty sure that I remember doing a video about that. And once you know the stages, you're in business, and the horsepower, of course. So on to the next one. Okay, so here we are bringing you the stopwatch method. Now this one might actually raise some eyebrows with you folks because this one requires the pump to be working. And you might say, why do you need to know what pump is in the well when it's working? Well, there's a lot of situations, and you might be surprised how often I actually have to go through this process of figuring out what we've got for a working pump. And oftentimes that involves me working for free. But anyways, that's all right. That's okay. So the stopwatch method, I guess I'll talk a little bit more about some examples of why you would need this information. So let's say you got a real estate transaction, trying to sell your house, and the person buying it wants to know how much water you can get out of this pump, or what have you. Just part of a real estate transaction, they maybe need it disclosed. Or another example, you're looking to add a garden onto your property, maybe a large garden, and you want to make sure that the pump that you have has enough capacity to handle the garden. So I don't know, there's a lot of different possible situations where you need to know what you've got in the well. So anyways, the stopwatch method is pretty simple. You look at the size of your pressure tank. So let's say you've got an 81 gallon pressure tank or a Wellextrol 255. And in a 40-60 configuration, so 40 to 60 psi pressure switch setting, you're going to have, I think, about 25 gallons of drawdown. And you could go to rcworks.com, pull up the Wellextrol tank. There's going to be a document or a specification sheet that shows you what the drawdown is at the different pressure ranges. So anyways, once you know what the drawdown is, you can open a tap. The best way to do this is if you have like a hose bib right at the pressure tank, so that you can run a hose out the door or whatever, and then open that tap until the pressure gets to the point where the pump's going to kick on, and then allow the pump to kick on completely, and then close that tap as quickly as you can as soon as the pump kicks on. So you hear that pressure switch snap, you close that tap, and you start the stopwatch all at the same time. So you're going to need 3 arms to do this one. Usually you just do it a couple times, that way you can kind of average your numbers. But anyways, you start the stopwatch, and now that we know the drawdown is, like what I say, 25 gallons or 21 gallons, we'll just call it 20. So now that we know that our drawdown's 20 and it took us, let's say, 30 seconds to fill the tank all the way up. So if we know that our drawdown is 20 gallons and it took us half a minute to fill up, then we're basically looking at a pump that does 40 gallons per minute, because if it had run for another 30 seconds, we would have gotten another 20 gallons out of it. So it's just a little bit of simple math to figure out what the fill rate of the tank is, so you can get a really good idea of what the flow rate is. So now that you know roughly what your flow rate is, and even being just kind of close is generally good enough, because if you know pumps, and maybe you don't, but they're typically in increments. So like you've got 5 gallon a minute pumps, some 7 gallon a minute pumps, 10 gallon a minute pumps, some 12 gallon a minute pumps, then you got 15, 20, 25. Those are pretty much your standard residential pumps. Now obviously they go to infinity and beyond, but in residential situations, you're typically dealing with something in that range.